On Wednesday, January the 15th, 2014, a passenger train derailed just outside Hilversum station. Due to a defect switch, the rear section of the train was suddenly directed onto the adjacent track, as a result of which the train derailed. A number of passengers suffered minor injuries, while serious material damage was caused to the track infrastructure and the train. How can a defect switch lead to a serious incident like this? The Dutch Safety Board conducted an investigation into the accident. The train carried around 550 passengers and was travelling from Enschede to Schiphol Airport. After a short stop in Hilversum, it passed switch 3B, just after the railway level crossing. Because of the defect switch, the rear section of the train was suddenly directed onto the adjacent track, as a result of which the train derailed. A train travelling in the opposite direction was successfully brought to a standstill, thereby avoiding a collision. A switch has two movable ends, the switch blades. They are operated by a point machine, in this case an AB switch. This point machine was equipped with a release mechanism containing a ring. Technical investigations revealed that the train derailed because this ring broke suddenly due to fatigue. First of all, the ring revealed finishing defects, making the ring more susceptible to fatigue. Furthermore, the fatigue fracture arose because over a long period of time, the ring was exposed to additional forces coming from passing trains hitting the switchblades with their wheels. This hitting action caused the switchblade to oscillate, thereby applying additional forces to the point machine and to the ring, for which it was not designed. The flangeback contact of the wheels was caused by poor maintenance. Various parts of the switch were so worn that they could no longer support the blade shifting. As a consequence, when shifting back and forth, the switchblade experienced so much resistance that it remained too close to the rail. This in turn meant that the wheels of passing trains regularly scraped along the switchblade. When the ring finally broke, the blade worked loose, causing the train to derail. The wear to the switch did not occur overnight. Maintenance could have led to repair. This was not the case. The investigation revealed that ProRail did not see any safety risk in flangeback contacts, and as a consequence did not consider it necessary to prevent them. Insufficient lessons were learned from several previous train accidents. For example, a scenario comparable to that in Hilversum occurred in a train derailment in 2007 in Greyrig, England. If the knowledge of this serious accident had been utilised, the parties could have known that flangeback contacts represent a safety risk that needs to be managed. Instead, the maintenance regulations imposed on contractors by ProRail were insufficient to prevent flangeback contacts. In this respect, the Dutch Safety Board notes that maintenance, more strongly than in the past, focuses on preventing train disruptions. Because the wear of the switch parts supporting the blades and subsequent flangeback contacts did not lead to such disruptions, insufficient attention was paid to these parts in maintenance.